Hey, what up, guys? This is Nick the Quant, and today we have another video for our highest mathematical edge pick. Yesterday, the San Francisco Giants on the money line cashed them out for a profit of, honestly, so we've hit five highest mathematical edge picks in a row. I mean, we've been absolutely just going insane. So yesterday the profit was 5.36 units. Yesterday overall, we went 3-1, profiting 7.38 units. So as always, if you want access to all of my sports betting plays, not just my highest mathematical edge picks, even though they've been performing fantastically, but again, I made even more profit yesterday with the help of my other picks. Please check out my X account at NickTheQuant44. We just hit over 200 followers, so I'm super blessed for that. So I want to say thank you guys for that. You can also check out my Instagram account, NickTheQuant. That's where I post more insight into really just the highest mathematical edge picks really in general. I post my daily results on my Instagram story there, and then I have testimonials, which is essentially, people posting about me, saying thanks for the picks, or if there's any like leaderboards I fall into. There's a account right now on X called Tail Slips. Shout out to them. They've been tracking cappers on Twitter who post their plays for free. So I'll post on my story where I fall in their leaderboards. They're tracking, I think, like up to 200 cappers now. Yesterday I was in first. Past 2 days I've been in first place. So I like to put stuff up there on, on my story as well, just so I'm being as transparent as possible. I want to be able to prove to you guys I have a reliable track record, and I'm not just, someone spewing nonsense. So saying that, we can get into today's pick, and as always, same agenda. We'll start off with what the pick is, the odds I'm getting it at, the expected value, how much I'm risking, and then the potential profit. And then I'll take you guys through the math of my ensemble model. We'll go through the 9 interior models, talk about how the calibration functions in those interior models, and then we'll get into the second and third layer calibration pertaining to now how the probability of that ensemble model's initial probability output changes. So saying that, today's highest mathematical edge pick is again the San Francisco Giants money line. So yesterday we took them. They beat the Cubs, I think 18-3. The day before that, we had the Blue Jays as a massive underdog against the Braves. That still to this point is my highest mathematical edge pick I've taken up to this point in the year. Profited 7.77 units. They beat Chris Sale and the Braves 7-2. The day before that was the Mets over the Mariners. They won 7-2, and the day before that was something else. But needless to say, a lot of profit amongst all these picks. I'll see you, bro. A lot of profit amongst all these picks. And so now we can get into really just the math going into this pick today, again, being on the Giants. So I got the Giants at plus 135 odds. Model probability for them is a 51.37%. The expected value is a 20.72%. And real fast, I just kind of I haven't really explained this as much. So when I talk about expected value, what we're talking about is, first you need to understand with probabilities, it pertains to a distribution of events. So it's when you calculate the probability of an event taking place, your initial thought is that when you're talking about, okay, the probability of like flipping a coin is 50-50 for heads or tails. So you think, okay, when I flip this coin, there's a 50-50 probability it's heads or tails. That is true. But when you get into something like sports or really anything that offers now significant amounts more of unpredictability, more variance, more variables at play rather than just a head or tails, you need to understand that a probability, while it does correlate to singular outcomes such as a sporting event, will this team win or will they lose? There's so much variance that can happen in a game that is simply out of control as far as what math can predict. So a probability is speaking to a distribution of events, meaning if you're predicting a team to win and you say they have a 51.37%, right? Like here I'm saying for the Giants, that means that in a distribution of outcomes, let's just say 100 games or 1,000 games, we could expecting that the probability is accurate, that in 51.37% of those games, the Giants will win. So where expected value comes in is when you're looking at the distribution of events, right? You have your lower bound, which is like your worst case scenario, meaning if you produce a probability, there's always the potential that the lower bound of the probability performs, which you can calculate using like a confidence interval, which would give you the beta value, which gives you like how wide that band is. So to kind of simplify this, let's say your team has a 65% probability to win. The probability is fairly accurate, but they get blown out. And let's say the lower bound of that probability was a 54%. That means that they underplayed something, they just didn't have a good game, so they kind of pulled down to that 54% or maybe even larger. And that's what can happen. And the flip side of that can happen, which is the upper bound, which means to say if a team at a 55%, or let's just say yesterday, the Giants were like a 52 or something like that, and they won 18-3. I'm sure if we did a conference interval on that, considering I don't have thousands of data points for each prediction right now, the upper bound of that probability is probably something plus 60%. So the Giants, considering how well they're playing, how bad the Cubs are playing, what we probably saw is the Giants performed at that upper bound of their probability distribution. Where expected value comes in is it's right in the middle of that, which is essentially expected value. That's what we're expecting to have happen because it's the mean of the probability. So as more games play, as we have more sample size, variance or randomness starts to smoothen, we can expect our results, whether teams are underperforming or teams are overperforming. The more games they play, we can expect this to happen. And they start playing as we expect them to. That's where this range, this expected range, that's where we want to be able to understand where there's actual financial value in our decision making. If we're basing our results on like best case scenarios when they're playing out of their minds, long term that's not going to hold. And if we expect teams to keep playing really poorly at their lower bounds, long term that's not going to hold. We need to base our decisions off of their expected value or their expected mean of performance. So now this is where you take into account the probability and their odds to calculate expected value. So expected value takes into account the probability of the outcome that I calculated, in this case the Giants being at 51.37, the probability that I'm wrong, which would be the complement of this, which would be like 48 point something, right? Just 100 minus 51.37. The profitability that I would get if my calculation's correct, and then the loss I would incur if my probability is wrong. You multiply those two together, the two scenarios, you take the difference. If the difference is a positive number, that means in the long run, you're making a financially correct decision. If it's negative, that means in the long run, this is not a financially rational decision to be making. Because again, we are assuming that both of these teams, we're assuming that we're making a decision not just on one game. We're making a decision on hundreds upon thousands of predictions. This is a long-term game. So if we're making that assumption, we need to be making mathematically or probability theory-based rational decisions every single time we bet because we're betting for the long term. So as we continue to accrue more and more sample size and our distribution now becomes larger, the reliability of the probability increases, but we can expect our results now to kind of revert to that mean, which is where that financial value is. And if there's a scenario where you've consistently been making decisions that are negative expected value, right there is when reality will hit and you will start to lose money. If you're making decisions that are positive expected value, truthfully positive expected value, meaning your probabilities are actually correct, as more sample size comes in and you start to regress towards that mean of the distribution, that's boom, you're going to be making money in the long term. So that's what that means. I'm trying to explain this as simply as possible. It's kind of hard to, but that's kind of what this means. And this applies directly to the stock market as well. If like you were doing option tradings, you could compute a probability of an option, being successful with whatever type of position you're taking. And you could say, okay, here's what my reward would be or my profit would be if this probability is correct. And here's what my loss would be if the probability is wrong. And you say, okay, now if I made this decision 100 times, would I make money or lose money? If you lose money over a span of 100 times, that's not a decision you should be making on singular outcomes. If you're someone who is betting or placing trades consistently. If you're betting just once, then okay, expected value really doesn't apply. But if you're, the vast majority of people are not doing that. Anyways, okay, so we can get into the math on this pick. Sorry about that. I just want to offer a little bit of insight on that because I always talk about expected value, just kind of like under the assumption that people understand what it is. And I'm a nerd for this stuff, and I'm always trying to learn. I'm getting into like base rate updating and a lot of these things to just continue advancing my model. And I don't know. Yeah. So, all right. Ensemble model. So again, my interior models are calibrated based on how the initial predictions perform in the real world. So the probabilities I'm saying are the winning rates of the initial predictions from these interior models. So model 1 has the Giants at a 52.25%. Model 2 has the Cubs at a 78.57%. Model 3 has the Giants at a 40.86%. Model 4 has the Cubs at a 64.86%. Model 5 has the Cubs at a 44.44%. Model 6 has the Cubs at a 51.61%. Model 7 has the Cubs at a 77.78%. Model 8 has the Cubs at a 50%. And Model 9 has the Cubs at a 72.73%. So what this does is it gives the Cubs an initial ensemble output. And again, I always say this, how much those probabilities I just spoke on, how much they influence this probability I'm about to say, depends upon how reliable those probabilities are, meaning how much sample size is present for each initial prediction. So honestly, I'm still doing research because my model is a little niche in many ways with how I'm doing the math. So I'm doing research on like exactly, if we're talking about probability theory, like predictive analytics, what I'm doing, like exactly what is the name. Right now, I kind of like calling it reliability modeling, but I'm gonna learn more. But as of now, I like to call this reliability modeling. So the Cubs get spat out as a 54.31%. So now here comes second layer calibration using empirical Bayes, which takes into account that model output and the amount of sample size. As sample size increases, the reliability of the probability increases. So now we rely more on just the actual empirical data or the actual outcomes. But as sample size is not large enough, we need to take into account still what that model is producing. So it's kind of like weighting both. So as of right now, when my ensemble model produces 54% probabilities, they've only been winning at a 41% rate on the season. So empirical Bayes pulls back the Cubs now to a 49.71%. Yesterday, they were in the same contrarian position. Not this same one. They were in a worse one, actually. But again, the second layer pulls them down. So, hold on. Sorry. There we go. Okay. So now we're going to take into account the market region, which is our third and final layer of calibration. We take into account the market region the Cubs are in today, and they're in a contrarian market region position. So the market region the Cubs are in today currently has a 46.61% win rate on the season. So relative to the market, this is disadvantageous. Not massively though, because each market region kind of fluctuates. There's market regions that have been consistently holding over 60%, and there's market regions that have been consistently holding below 50%. And the Cubs are in a market region today that is in one of those. So we talk about a 46.61% win rate relative to the Cubs pricing, which was minus 163 at the time of my analysis. That is a significant disadvantage. And the contrary of this, which would be around 53%, meaning the flip side of this market region being a 53% win rate, for the Giants is very advantageous relative to their pricing. So mathematically, it's advantageous to the Giants, disadvantageous to the Cubs, and pricing, it is significantly advantageous to the Giants and significantly disadvantageous to the Cubs. So we're going to apply this as our third and final layer of calibration to the Cubs, which finalizes the Cubs being, let me just get that, a 48.63% probability, and the complement of that, or the opposite, just being the other team, being the Giants at a 51.37% probability. So that brings us full circle back. We got the Giants at a 51.37% probability at plus 135 odds, denoting a positive expected value of 20.72%. I'm using a fifth Kelly now after another successful week. I'm trying to, reduce my Kelly, which increases my leverage or increases my risk as performance also increases. So we have that kind of concurrent relationship as these probabilities become more reliable. So we're risking 3.06%, or for me, 3.06 units, as 1% of my bankroll represents 1 unit, for a potential profit of 4.13 units. So again, I appreciate you guys for tuning into this video. If you want access to all of my free sports betting picks and plays, you can check out my X account at NickTheQuant44. But let's keep winning. So I will see you guys.